This is the Unit 4 vlog on solving systems. In a system of equations, you are basically given two or more functions, and you must find the points they would intersect at if they were graphed on the same plane. Sometimes this may be used in real life, or if you wanted to see when two runners traveling at different speeds would cross paths, or when two people making money at different rates would have the same amount of money, or even if two tennis balls are thrown from different heights where they would meet. An example of this would be the equation x minus 2 squared plus 4 equals 2x plus 3. This could be written out as two separate equations. X minus 2 squared plus 4 is a quadratic function. You can tell because x in the equation is being squared, which will create a parabola. 2x minus 3 is a linear function. You can tell because it is written in y equals mx plus b format. There are two different ways you can solve for a system of equations, algebraically and graphically. When solving graphically, you just graph the two equations as separate functions but on the same set of axes, and find the points where they intersect at. For this equation, we will be graphing y equals 2x plus 3 and y equals x minus 2 squared plus 4. Let's start with the easiest one, y equals 2x plus 3. From this equation, we know that the y-intercept is 3 and the slope is 2. So the graphed line would look like this. If you would like more information on how to graph lines, you can watch my video on linear functions. Now we can graph the parabola. From the equation x minus 2 squared plus 4, we know that the vertex is 2, 4, and the parabola is facing upwards. Now you can create an xy table in which you plug in numbers for x and solve for y to find specific points on your graph. For example, if you plugged in 4 for x, the equation would be y equals 4 minus 2 squared plus 4, which would make y 8 and would mean that 4, 8 is a point on the graph. Do this with a few more points and graph the points as you go and connect them, and your graph should look something like this. For more information on how to graph a parabola, watch my video on quadratic functions. Now that both of your functions are graphed, look at the points where they cross paths. In this case, it seems to be 5, 13, and 1, 5. Now let's solve this algebraically to check our answer. When solving algebraically, you set the two equations equal to each other, as written in the problem, x minus 2 squared plus 4 equals 2x plus 3. So let's move all the terms to one side so it can equal 0 so we can solve for x. We can do this by subtracting 2x and subtracting 3, so everything on the right side of the equal sign is equal to 0. But if you subtract from the right side, you must do the same thing to the left side, creating the new equation x minus 2 squared plus 4 minus 2x minus 3. Now let's simplify even more by splitting up x minus 2 squared to x minus 2 times x minus 2 and multiplying these together. X times x is x squared, x times negative 2 is negative 2x, x times negative 2 is negative 2x, and negative 2 times negative 2 is 4. So now our equation will look like x squared minus 2x minus 2x plus 4 minus 2x plus 1. Now we add the like terms, and you will have the simplified equation x squared minus x plus 5 equals 0. Notice how this looks exactly like the standard form of a quadratic equation, ax squared plus bx plus c. This means you can solve for x just as you would when solving for x in a quadratic, using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. I won't go too into depth about the quadratic formula, but next we will plug the variables into the equation. Our a is 1, our b is negative 6, and our c is 5. So x equals 6 plus or minus the square root of 6 squared minus 4 times 1 times 5 over 2 times 1. This can be simplified to x plus or minus 4 over 2. Because of the plus or minus, we know there will be two solutions. If it is 6 plus 4 over 2, the x will be 5. If it is 6 minus 4 over 2, the answer will be 1. Well, all we have is the x's of the ordered pairs right now, but we do know that the parabola and the line will cross at two different places because there are two solutions. To find the y of the ordered pairs where they intersect, you have to plug the x's back into one of the functions. Let's go for the linear function because it's the easiest. y equals 2x plus 3. If we substitute x with 5, the answer for y will be 13. So one of the points the two functions will cross at is 5, 13. Now let's find our second point by plugging 1 in for x in y equals 2x plus 3, giving us 5. So our points of intersection are 5, 13 and 1, 5. This concludes the vlog on solving systems of equations. Thank you for watching.